Hello. So we are learning to how to do reflection across line y is equal to -3 or y is equal to any constant. For this, for a general, we'll derive a formula also. So we'll do two problems for y reflection across y is equal to k when k is positive and negative. And same we'll do with x when x is negative and positive. So let's first take the reflection across line when y is equal to -3. So suppose this is the graph. So this is the line y is equal to -3. So reflection across this line. So we'll do it algebraically. Okay. So in this case, when the reflection is across line y is equal to -3, x remains same because it is the reflection across horizontal line. So suppose there is a point here, y is -2, y is suppose 3 and -2. So 3 remains constant and it will be reflection. So it will be this side. Okay, reflection across the. So we don't have to worry about x. X remains the same. Okay. And for y, we have to calculate the vertical distance from the original point of the y coordinate. So from to the line y is equal to -3. Okay. So this is the line y is equal to -3. So first thing is calculate the vertical distance okay, from y coordinate to the line y is equal to -3. Okay, so suppose for j, if we take -5, or if the y coordinate is suppose y, so this will be distance will be by -3. Okay, so this will be y plus 3. Okay, distance of suppose in this case -5, -3. So the distance will be -2. Okay. Now the second step will be move the same distance on the other side. So other side of the line y is equal to -3. Okay, so suppose this is -2 you got. So to the other side of miles. So that will be -3 negative distance. Okay, which we got this. Okay, so -3 and negative distance. Move the same distance on the other side of y is equal to -3. So this will be -3 negative y plus 3. Okay, so this will be -6 negative y. Okay, So this will be for this point for J, we got negative 2 as the distance, but if we do like this, it will be negative 6 minus y. Okay, so that will be the minus 5. So this will be negative 1. Okay, so our coordinate J dash will be 3 negative 3 comma negative 1. But we can generalize the formula also. For this, it would become negative 6 negative 5. So for K dash would be x coordinates remain same, and negative 6 negative 1. Okay, so that will be 4 comma negative 5. Okay. So this K dash would be 4 comma negative 5, and L dash would be 0 negative 3 negative 6. We use this formula which we got it, and negative y. So it will be negative 3. Okay, so this will give us 0, x coordinate remains same, and this will be negative 3. So this will be 0, negative 3. And we can also see if we put this distance as, suppose we put this y is equal to k. Okay, we can generalize this formula also. So if we put here, it would be y minus k. Okay, and if we do this, 3 minus y, this was k, sorry. So we are generalizing it, putting k. So k minus, this was y minus k. Okay, so this would be, okay, so this would be 2k minus. So this formula will work for every question. Okay, when it is reflected across a line y is equal to k. Okay. So we'll take a second case. In this case, we did when y was a negative value. Across the line, y is negative 3. We'll take another case. Okay, but this is a general formula. Okay, where y is the coordinate of the point and k is the line across which we have to do the reflection. So in this case, what we are doing is reflection across line y is equal to 1. So again, we derived the formula last. So we can use the same 2k minus y. We can also check. Okay, so this k is 1. Okay, so j dash becomes 2. X coordinate remains same because we are reflecting across a line y is equal to 1 like this. Okay, so j is 2, 4, and so this is, J dash becomes x is 2 and 2 minus 4. So minus 2. Okay. And k is minus 4 minus 2. So this becomes k dash is equal to minus 4 and 2 minus minus 2. So 4. Okay. And L is negative 1, 0. So this is L dash will become negative 1 and 2. We can also check geometrically. So this point J is 2, 4. Okay. And this is the line y is equal to 1. Okay. So J is 2, 4. So this is 1, 2, 3, 4. Okay. This is J 2, 4. Now we see that it is 3 units away from y is equal to 1. So we do it on the other side. Okay. So this is 1 and 2 more, 2 down. So it will become, this is 3 units. Okay. So this should be also 3 units. So 2 down means y is equal to, this is negative 2. Okay. So j dash becomes 2 negative. Okay. So this is 3 units. Okay. So same way we do like we did in the earlier one. First we find the distance. Okay. Keeping the x coordinate same. Okay. And so keeping the x coordinate same gives x. And we calculate the vertical distance from original point. So y coordinate to the line y is equal to 1. So that distance is y minus 1. Okay. So in this case, suppose this is 2 and this is 4. So it becomes 3. Okay. And then we move the same distance another side. Okay. So this will be, so this we got 3 and we move the same distance other side means 1 minus 3. So we get minus 2. So we get this. Okay. So now let's do with the x coordinates. Okay. So now we'll do the reflection across the line x is equal to 2 or x is equal to k. Okay. In the previous last two questions were the reflection across the line y is equal to k, and we did k as positive and negative both values. So now we are doing reflection across x is equal to 2. So when we do, we know y coordinate here remains same. Okay. Okay, so this is okay. So this is suppose x is equal to this is x is equal to this x is equal to 2. So first we find the distance of x coordinate from x is equal to 2. So that is x minus 2. In this case, if we take j, it will be 1 minus 2. Means it is minus 1. Okay. And in this, now we find the distance, now we move the same distance on the other side. Okay, of line x is equal to 2. So this will become, it was x is equal, so it will be 2 minus x minus 2. Okay, so this will become 4 minus x. Or in this case, when minus 1 we already got, so it will become 2 minus minus 1. Okay, so it will be 3. Or in this case, we say 4 minus x. So 4 minus 1 will be 3. So j dash we get it as y coordinate remains same, and this becomes 3 negative 1. We can use this generalized formula to get k dash, which will be 4 minus x means 1 0. Okay, and L dash again 4 minus x means 4 negative 4. Or we can also generalize the formula for this is two k minus x, whatever we have got here. So generalized formula for reflection across x-axis is 2k minus x and y. Okay, so this is now the fourth case we will do is the reflection across x is equal to negative, x is equal to negative any value, maybe negative 1, negative minus 1. Okay, so in this case, we are reflecting across the line x is equal to negative 1. So this is the line x is equal to negative 1. So in this case, y coordinate remains same because the reflection is across the line x is equal to negative 1. So y coordinate remains same. Okay. And now, first thing is we find the distance of x coordinate from line x minus 1. So that will be x minus minus 1. So it is x plus 1. Okay. And then we move the same distance to the other side, x is equal to minus 1. Okay. So that will be negative 1, negative x plus 1. Okay. So suppose like this x is 2. So the distance from this would be 2 plus 1. So we will get 3. So distance of 2 will be 3. Right. So if we go back, we have to go back 3 in this direction. Okay. So this will be negative 1, negative x, and negative 1. So negative 2 minus negative x. So this will be negative 2 and negative 2. So negative 4 in this case. So here what we got 3, here the coordinate we got get as 4, j. So j dash we get it here as 4, negative 1. Sorry, negative 4 and negative 1. Okay. Same way, if we can generalize the formula also. In this case, if we it will be 2k minus x and y. So if we use this formula, then k dash we get is k is here negative 1. So negative 2, negative 4. So it is negative 6, negative 5. And L dash is negative negative 2, negative 3. So this is negative 5 and comma 1. Okay. So we can use this formula also, or we can do algebraically like this. Okay. If you need help, please feel free to let me know. Thank you.